This is my Chapter 9 reassessment. My question says, you're playing with a yo-yo of mass M on a low mass string. You pull up on the string with a force of magnitude F and your hand moves up a distance D. During this time, the mass falls a distance H and some of the string reels off the yo-yo's axle. So for the first question, what is the change in the transitional kinetic energy of the yo-yo? So first, since it said transitional kinetic energy, I realize this is going to be a point particle system. The system is just going to be the point particle of the mass M, and we know that energy is going to equal the change in the transitional kinetic energy. This is a diagram I drew of the yo-yo. The force by the hand is being pulled up. M times G is the gravity pulling down. D is the distance that the hand is pulling it up, and H is the height or the distance that the mass falls. And so we know that the change in translational kinetic energy is equal to F, the force, times change in X, which is the change in distance of the center of mass. And since we're dealing with a point particle system, we only care about the center of mass. So I actually redrew that diagram just for the point particle system. And so I drew the point particle right here, the mass M with the force pulling up, mg pulling down, and the height pulling down of the mass falling a distance of h. So we can rewrite the translational kinetic energy as the force minus mg times change in y at the center of mass. And change in y is just going to be negative h, since it's moving down in a negative direction because it's opposite of the force. So it's going to be negative. And that comes out to be that the translational kinetic energy is the force minus mass times gravity times negative h. And we can rewrite that as mg minus f all times h. So then I went on to saying, what is the change in the rotational kinetic energy of the yo-yo, which spins faster? So since the point particle system only deals with translational kinetic energy, we obviously have to use the real system. And so the system is going to be the mass and the string. I defined the change in the system, the change in energy of the system as the work by the hand plus the work by earth, and we can expand that to the change in translational kinetic energy plus the change in the rotational kinetic energy being equal to the force times the distance that the hand is making the string move up plus negative m times g times negative h, which those negatives are going to cancel, and you're just going to get m times g times h, and those are going to cancel on both sides. Once you expand this out again, we had got the change in translational kinetic energy earlier, so we just plugged that back in here and solved for the change in rotational kinetic energy, and we got the force times the distance that the hand made it move up plus the height h, which is the distance that the yo-yo actually moved the mass, which was the yo-yo actually moved down.